Welcome back to CeADAR Lighthouse AI Digital Twin Project video service. In our previous video, we explored the structure and life cycle of AIDT. Today, we are diving deeper into the captivating technology as we focus on the front-end and back-end components that bring AIDT to life. Just to refresh your memory, AIDT are virtual replicas infused with artificial intelligence, enabling us to monitor, analyze, and interact with the physical world in remarkable ways. In this video, we will uncover the immense possibility of the front-end and back-end of AIDT. The front-end serves as a gateway, offering a user-friendly interface and an immersive experience. On the other hand, the back-end, a complex network of data processing, storage, and analysis. It breathes life into AIDT, enabling them to make sense of vast amount of data and generate invaluable insight. But what truly sets AIDT apart is the seamless integration of these components. The front end and back end collaborate, exchanging information and working together to create a truly immersive and powerful digital twin ecosystem. Now, let's turn our attention to the front end of AIDT. At its core, the front end of AIDT focuses on two essential aspects: the user interface (UI) and the user experience (UX). The UI includes visual and interactive elements that allow users to engage with AIDT. This includes elements such as dashboards, visualizations, and control panels. These components are carefully designed to present complex data and insights in an understandable manner, making it easier for users to monitor and interact with AI Digital Twin. At the same time, the UX focuses on creating an intuitive journey for users as they navigate and interact with AI Digital Twin. UX designers use principles of information architecture, interaction design, and usability to ensure that users can access the designable function, receive the timely feedback, and have satisfying overall experience. Let's take a closer look at some examples and possibilities of front-end elements in AIDT. First, dashboards are typically used to present real-time data, key performance indicators, and actors in a visible, appealing, and easy-to-understand format. Dashboards provide a consolidated view of key metrics and insights, enabling users to monitor and analyze real-time data at a glance, like digital twin of water cube applied from ARUP is an AI digital twin for smart city management that incorporates a dashboard with widgets displayed live data on energy consumption and traffic flow, air quality, and waste management. And the next is data visualization-oriented design. This front-end design approach focuses on the presenting complex data in a visual, appealing, and easily understandable format. Like the graph shown in here, the AIDT for financial analysis that utilize iterative charts and the graph and the data map to visualize market trend, portfolio performance, and the risk analysis. And the 3D visualization design approach leverage 3D visualizations to provide users with a spatial understanding of complex data and the relationships, like the AIDT for urban planning that utilize 3D visualization to showcase city infrastructure, zoning regulations, and population density, enabling stakeholders to assess and plan future development. And the augmented reality interface, I think, is the interesting. The AI interface designs digital information into real-world environment to enhance the user perception and understanding of the physical world. For example, the front end of AI-based artificial intelligence digital twin used in industry maintenance allow technicians to use AR devices to visualize real-time equipment data, assess commands, and receive the real-time maintenance information. And after talking about AR, the next step is definitely to introduce the use of virtual reality, the VR interface in AIDT. And the VR interface immerses users in a virtual environment that allows them to interact with AI digital twin in simulated and interactive way. Like VR-based front-end design of the AIDT used in architecture design enable users to walk through the virtual building, explore the different layouts, and modify the design in real time. And the last design, the front-end design should be responsive and optimized for mobile devices. That's allowing users to access and interact with AIDT on their smartphone or tablet. Like a responsive front-end design for AIDT for industry process in factory design shop, where manager can access industry data specific the parameter changes like so on in real time on mobile devices. I think there are many more design approaches waiting to be discovered future. So now let's shift our focus on the back end of AIDT. While the front end provides the user interface and the interaction, the back-end acts as the powerhouse, processing vast amount of data, performing complex calculations, and driving advanced analysis. The back-end is responsible for the behind-the-scenes operations that enable AIDT to deliver meaningful insight and actionable outcomes. Let's explore some key aspects of the back-end. Here is a complete diagram of AIDT architecture, in which first we need to perform data ingestion and integration. The backend handles the ingestion of data from various sources, such as the sensors, database, and the external system. It ensures seamless integration, processing, and storage of data for analysis. And then is the back-end process and analyze the data to extract valuable insights and patterns. It utilizes machine learning algorithms, statistical models, and data mining technology to identify correlations, trends, and anomalies. And then the backend will employ machine learning and AI algorithms to learn from the data, improve the predictions, and enable advanced functions. It can include algorithms for anomaly detection, pattern recognition, and the predictive modeling. And then we can use the cloud computing infrastructure to handle the scalability and computational demands of AIDT. It allows for efficient storage, processing, and scalability of data and algorithm. This aspect of the backend from the basis of the AIDT, enabling to process, analyze, and interpret large amount of data. Now that we have explored the back-end of AIDT, it's time to understand the significance and the possibilities of integrating the front-end and back-end components. The front-end can provide real-time monitoring of the data stream and generate alert or notification when predetermined thresholds or anomalies are detected. Like this figure, this is a real-time digital twin instance being created to track telemetry data for that model using machine learning algorithm. A model that provides data updates to this real-time digital twin for monitoring of machine learning algorithm to detect the anomalies and generate alert when they occur. Like the scale-out model development tools allow users to use this algorithm to add the spike detection for selected parameters. In addition, it is often useful to detect the unusual but subtle change in parameter telemetries over time. For example, if the model temperature is expected to remain constant, but the detection temperature rise slowly, it may not be observed. To address this need, the tool allows users to detect and report on individual parameters, inflection points in telemetry using a linear regression algorithm developed by the scale-out. And the integration of the front end and back end can to forecast future trends and outcomes, enabling users to make informed decisions. This diagram shows the AIDT used to monitor the urban environment. It will allow multiple scenarios to be replayed, while also providing a platform for simulating the potential impact of virus interventions previous to implementation in the real world. For example, a replay scenario in the area of urban air quality could be revisit historical data stream or to make prediction of the pollution in a specific area. And also, the front end can enable users to conduct virtual simulation and experiments to test different scenarios and analyze potential outcomes. In this image shows a team using AIDT to simulate a machine learning enhanced robot control strategy that combines a nearest neighborhood approach to path planning, cluster analysis, and the artificial neural network of obstacle detection. And the integration can also adapt and personalize the user experience based on the individual performance, historical data, and the user feedback. For example, AIDT for personalized healthcare can tailor recommendations, treatment plans, and health insight based on individual medical history, life cycle, and genetic data. And the integration of front end and back end can incorporate gamification elements and interactive features to engage users and motivate them to explore and interact with the AIDT. Adding the game elements to traditional learning to make it more engaging in the gamification of education, like in this feature. Combining the digital twin will enable students to engage and complete to learn in simulated environment. In addition, the use of AIDT technology to combine and visualize data will improve decision making, leading to immersive learning experience and enable effective planning and action. This use will also enable our to correct any shortcoming in decision before they are brought to life. Through the front end, we have witnessed how intuitive interface data visualization, personalized experience, and immersive technology enhance user engagement and understanding. The back end, with its data processing, analysis, machine learning, and integration capabilities, provide the foundation for generating meaningful insight and driving intelligent action. The integration of the front-end and back-end components creates a comprehensive ecosystem where the data flow work together, real-time insights are generated, and users can interact and make informed decisions. This integration amplifies the capabilities of AI digital twins, enabling a holistic and efficient use experience. And this is all to this video. Thank you for joining us on this journey into the world of AIDT. We invite you to subscribe our channel and stay tuned for more fantastic contents on the latest advanced use case study and insight on AI digital twin. Thank you, and see you in next video.